Hey guys, welcome back to my channel. Hope you are doing extremely well. This is your very own Mars Coder, and without any time waste, we are going to continue the GFG POTD series. As you can see, we have already completed 26 of our days, and today is 27th day. All right. So today's problem is remove k digits. Let us have a look. What does the problem say? So the problem says that we have been given an integer array in the form of a string as an input. Suppose you have an integer 149, then it has been given to as input as string of 149. Pretty simple, okay? And you have been given an integer k. Now, you have to remove k digits from the given input string. You have to remove k digits from 149 in this example, such that string transform into minimum possible. All right, minimum possible integer. All right. So, suppose you have been given an integer as 149 as your input string and you have to remove only one digit from it. Okay. And you have to return the minimum possible number formed after removal of the digit. So in this, we have three options: either to remove one, that will give us 49, either to remove this 4, it will give us 19, and either to remove this 9, this will give me 14. So as you can easily see, 1 4 is the minimum possible, 14 is the answer right there. All right. So this is our input and this is our output. I am sure that you have got the hang of the problem, that what you have to do, all right? So it is very important to understand that what you have to do before attempting a problem, all right? So if you see the problem again, that we have to remove k digits, can you think of a brute force solution? Brute force solution, all right. For the brute force solution, what you can do is select all combinations of k digits which are possible. You might wonder, how did I come to this approach? I am seeing that we have to remove k digits. It is not mentioned which k digits, how k digits, what is the procedure to select the k digits. We have just to select k digits. So I am saying select all the combinations of k digits possible. Okay. After that, try removing each one of them and keep minimum possible string as an answer. Right? Suppose this was the approach we used here. We had to remove one. So there were only three possible cases. Either remove this one, or this one. So we applied brute force solution in finding the answer 14. Alright. What is the time complexity of this approach? As you can see, in a string of length n, selecting n k letters, how many possible combinations are possible? That is n c k. So it is actually giving me an exponential time complexity. Not to answer, it will use recursion to get all the combinations. It cannot be used. It cannot be done using the for loops, I guess. And it will be the exponential time complexity, and the space complexity will be as usual of one. Pretty inefficient, right? No one wants you to give a solution in exponential time complexity, unless and until it is the only way. Yeah. So now, what can we do to optimize it? All right. So let's move towards the efficient solution. Moving towards the efficient solution, let me ask you some few questions, all right? Suppose a string given to you is 5555 and you have to remove one digit from it. Okay. What will you do in this case? You will say, Bhaiya, it doesn't matter which one I remove. I can remove this one, then also I will get triple five. I can remove this one, and then also I will get triple five. I can remove this one, then also same, this one, then also same. So my answer is triple five no matter which one I remove. Okay, I say absolutely correct. Now I say you have triple five one. Now which one will you remove? So you say there can be two cases now. Again, we have to remove only one. Just keep in mind, right? So now you will see there are two cases. Either I can remove one from this one or this one. That is, either I can remove any of the five or the single one present. So what will be the output? If I remove 5, it will give me 551, and if I remove 1, it will give me triple five. Again, 551 is less than triple five. So it gives me an inference that I have to remove greater digit. Yeah, you can see that 5 was greater than 1, and removal of 5 gave us a smaller digit than removal of 1. Yeah, can we do this one more time for 1 triple five? Okay. Again, two cases, either this one or one of these five. It will give me, removal of one will give me one triple five as usual, and removal of five will give me one double five. Again, removal of five gave us a smaller digit. So this has got some priority points right now. Priority is high or removing the greater digit. All right. Now, suppose the input array given to you is 5, double one, 5. Now, will you say that there are also two cases, remove either 5, remove either 1? No, because this 5 and this 5 have got a discontiguous right now. And removal of these 5 will lead us to different examples. So, there are three cases possible here because these one are contiguous. So, removal of either one of these or this or this. Removal of this will give me double one five. Removal of one of these will give me 515, and removal of this will give me 511, and as you can see this is my smallest. So this example also states that I have to prioritize my MSB, that is most significant bit, that is present on the leftmost side, then right sides. This is the only one. Yeah, correct. So these are the two golden rules for this question. Two golden rules. All right. Now, how will we use them? Okay. I have to draw an inference now. Suppose the input array given to you is 5, 4, 3, 2, 1. You have to remove any one digit. Okay. So you will see, you will automatically think of removing 5 because the above 2 points are mentioned on the 5 only. That remove the greatest digit. 5 is the greatest digit, okay, and remove the leftmost digit. Again, true for 5. So you will remove 5. Okay, let me check if that is true. If I remove 5, anything, it will be 4, 3, 2, 1. Okay, but what if I don't remove 5 and choose any other digit? Now it will be a 3-digit array, but 5 will come at the starting. So you are correct that 4, 3, 2, 1 should be my answer. Removal of 5 is the key to this problem. All right. Now discuss over 1, 2, 3, 4, 5. A key point to note here was I forgot to mention that this is a decreasing array. Alright. So what did you do? In a decreasing array, as soon as you saw that 5 and you move over to 1 and move over to 4, you see that 4 is actually less than 5. So discard 5 and return the answer. Alright. What if there was 2? You will say 5, discard 5. 4, then move to 3. You see 3 is less than 4. So discard 4 and your answer would be 3, 2, 1. Correct? Yeah. So decreasing array has this property. Now I am taking example of increasing array. You will say there are 5 possibilities now. Remove either one, it will give me 2, 3, 4, 5. Then removal of 2 will give me 1, 3, 4, 5. Removal of 3 will give me 1, 2, 4, 5. Removal of 4 will give me 1, 2, 3, 5. And removal of 5 will give me 1, 2, 3, 4. Again, you see, removal of 5 is providing me with the with the smallest possible number possible. Yeah. Removal of 5 is giving me the required answer. So, What am I doing? I'm seeing that 1 done. I come to 2. I see 2 is greater than 1. Okay, pushed into the whatever data structure we are storing. Okay, come to 3. You see 3. So, okay, push 3 is again greater than 2. 4, again greater than 3. Okay. Now 5, again greater than 5. Now I have to remove 1. I have to remove one digit. So remove the last digit possible. Okay. And the answer will be 1, 2, 3, 4. So what is our approach? Our approach is to maintain a monotonic stack in increasing order so as to reach our goal. Okay. So what are we doing is, suppose the number given to you is, let me take a good number for the example, that is 1, 4, 3, 6, 7, 8, 5, 2. This is my input number. My algorithm would work like this, that I have a stack. Okay. I will push 1 to the stack. Suppose I have to remove 3 digits from it. Okay. I will push 1 to the stack initially. Okay, pushed. Keep my pointer at the 4. Now, if 4 is greater than the top element of the stack, then push it. So 4 will come here. Okay. It moves to 3. Now 3 is actually less than 4. So for that, remove the top element, decrement your k, it will be 2, and then push your element 3. Alright. Now 6, again greater than 3. Coming to 7. 7 greater than 6, 7. 8 greater than 7, 8. Now coming to 5. As I step onto the 5, I see that 5 is actually less than 8. So decrement the k and remove 8. Alright. 5 is actually less than 7 also. 7, 0. But now k has reached maximum. That we have removed 3 digits. That were 4, 8 and 7. In that case, push your 5 and then push your 2. Now these are the numbers that will form your answer, but these are present in reverse order. Why reverse order? Because you are pushing to the stack. So for the removal, for getting the answer correct order, what can we do? We can say take another stack, push the elements into that. That is, it will be 2, then 5, then 6, then 3, then 1. And my answer would be, remove the elements from this stack now. It would be 1, then 3, then 6, then 5, then 2. All of you can check. This is the minimum number possible after removal of 3 digits from this input array. Okay, this is my algorithm. This is my algorithm. Let me continue writing the pseudocode for it real fast. Okay, yeah. So my pseudocode would work something like this. That is, if k is equals to 0, or if k is equals to n is my length of the string. In this case, return string, because we cannot edit string, k is equals to 0. And if k is equals to n, remove all the characters of the string, so it will return 0. Sorted. Now I will keep a stack of characters, name it as st. All right. Now for int I equals to, and push first element also, st dot push si, as I mentioned, pushing 1, right? If you remember, for int I equals to 1, I less than n, I plus plus, what we have to do now? While stack is not empty and stack dot top is greater than si and k is not equals to 0. In that case, what you have to do is decrement your k and pop the element from stack. Okay. After this while loop, st dot push your si. This for loop will give you this stack. Okay. Now I have to retrieve this stack from, I have to retrieve this stack from this stack. Okay. So how will you use? Suppose this stack is stack 2. So in stack 2, what I will do? Now suppose here I'm not getting that case, but it is possible that the first five elements are 0, 0, 0. That is, stack has top five elements as 0, then 0, then 0, then 0, then 0. But I don't want any leading zeros, correct? For that case, what I'm doing is I will remove all these digits. Okay. But suppose the stack only contain five zeros. In that case, what I will do is I will remove the top four. So what is the condition I'm using? That while stack one, this was a stack one, okay? Stack one dot size is not equals to one, and uh, stack dot top equals to zero. In that case, stack dot pop, st1 dot pop, sorry. Okay. This will make my pre-processed stack complete. And after that, I will push all the elements of the stack one, push all the elements of stack one into answer. And after that, push all elements of stack 2 into, this is stack 2, right? Stack 2. And then push all the elements in stack 2 into the answers in string. And after that, return your string. This is my pseudocode for this question. And if you observe, we have done it in O of n because we have run this loop one time. So O of n for this one O of n, for this one O of n, for this one O of n, and the sum will give me O of n only. This is my time complexity, and the space complexity will be O of 1. Okay, I hope you are getting my point. I hope you're not confused anywhere. If you are confused, drop down a comment. I will explain the part again. Okay, I will make a new separate video, or I can come on live if you insist and explain you the part. Okay, now can we code it real fast? Yeah. So coming back to the code, as discussed in the pseudocode, my int equals to s dot length. Now the base case were if k equal to 0, in that case return as it is, else if k is equals to n, in that case return 0, correct? Now first step was to create a stack of char and name it as st1. Then st1 dot push s of 0. All right, now a loop will traverse from first index till the last index I plus plus. After that, while my stack is not empty and my stack 1 dot top is greater than the element I'm about to push, and my k is not equals to 0. That is, I have the capacity to remove the elements. In that case, k will be decremented. Also, it is capital K here, and stack would be popping an element out. After that, stack 1 would inculcate my ith element. Okay, now after this loop, there is a possibility that k is left with me, that the stack has not removed all the elements. So for that case, remove from the last one. That is, while k is not equals to 0, stack 1 dot pop. Alright. Now initializes in a second stack, name it as st2. Okay, now while uh, removing the, what do we say, yeah, removing the topmost while Now, while st1 is not empty, what will you do? st2 dot push st1 dot top, and st1 will pop an element out. After this, that strategy, that while st2 dot size is not equals to 1 and st2 dot top equals to 0, in that case, also stack of type of st2 is char. I mentioned it integer by mistake. In that case, st2 dot pop. Now consider a string res as empty string right now, and then while st2 has not become empty, res will become equals to st2 dot top and then st2 dot pop. After that is the final step, the most important step, that is return your result. Hope the code will work using compile and run. There has been a mistake in the typing, that is spelling of length. Let us see now for compile and run now. Working fine. Try it for submit. So the code has worked fine for submit also. Hope you like my video, hope you like my explanation, hope you like my effort, and please keep watching me, and please, if you have not subscribed my channel, please subscribe it. And for the subscribers, thank you very much. It has motivated me a lot. And see you tomorrow with a new example and with a new spirit. Thank you for watching. Have a nice day.